Yeah, the voice is clear now. Please confirm once. All right, okay, now everything is clear, right? Chalo. So we are going to continue our session. So this was another session on acid and base. Now, okay, right? Chalo, very well. So guys, acid and base, we are going to continue to the solvent system. And along with the solvent system, we are also going to talk about some questions. Okay, we are also going to do some important questions. So before moving onwards, let me quickly remind you कि organometallics is completed in the plus classes, all the important topics. Now we will be doing the practice very soon in the crash course on inorganic chemistry. तो यहाँ पे होने वाला है practice, and here we were doing the concept. Okay. So yes, all right. Bioinorganic has already been started. So this is what we are going to do, guys. For the next few days, we are going to practice inorganic all the important topics. And these are all the topics that I teach on Unacademy Plus. So if you want, you can check out my profile and check out all the course pages. For all those who are joining new, guys, please see the course pages right from the month of July. Okay, that's the new session where we had started, and that's where you will see all the topics. So this is our second session on acid and base. Main group का भी एक session हो चुका है. There will be more sessions on main group and coordination. As you can see, this series is going to continue in the month of November as well. November में हम करने वाले हैं organometallics on the YouTube session. ठीक है? So yeah, this is the plan that we will continue organometallics, some really important topics on the Unacademy YouTube channel. और अगर आपको join करना है Unacademy Plus, then an offer is going on right now, that is your 24 plus 3. If you're taking a 24-month subscription, you'll get 3 months extra within the same subscription package, and this is applicable from 14th to 20th. ठीक है? तो ये 14th से लेकर 20th अक्टूबर तक ही valid है. Okay, so just informed you all. Now moving onwards quickly to start our topic. Okay, so today's topic of discussion is acids and bases basically, right? And we are going to continue with the solvent system. So, how many of you remember that in the previous session we had talked about water as your solvent, then ammonia as the solvent? Yes, liquid sulfur dioxide as the solvent. Okay, yes, good evening, guys, once again. So, what we are going to do is we are going to continue talking about the same thing. और आज हम लोग बात करने वाले हैं liquid hydrogen fluoride. Okay, first of all, we are going to begin with this, talking about this as our solvent. And along with that, we'll move onwards to another solvent system like your BRF3. This is also very, very important. You get a lot of questions asked from here, right? All the interhalogen compounds. Okay, yes. So, first of all, the auto ionization. Yeah, this is the first thing that we always see. सबसे पहले auto ionization देखते हैं, whichever solvent we are talking about. Yes, good evening guys, all of you, welcome once again. So auto ionization for the HF, see there was a question also, I made you do it in the plus class, right? That when you are breaking this down, when you are breaking down this molecule HF, it's going to give you some ions, H plus and F minus, right? Very simple ions, very simple cleavage. But what happens is, in the hydrogen fluoride solvent, when we are taking the solvent, when we are taking pure liquid hydrogen fluoride, then there is definitely going to be hydrogen bonding like this. Okay, so if there is hydrogen bonding, one molecule of hydrogen fluoride is going to stabilize this proton. So just like you don't have H plus in the aqueous solvent, right? You have the hydronium ion for the same reason, because of hydrogen bonding, because of the strong bonding, coordinate bonding with oxygen. So here you have the same thing. one HF is going to stabilize the H plus to rather give you H2F positive, okay, and one HF molecule that is going to stabilize the F minus. All right, so that makes HF2 negative like this. So these are the two species you are going to get by the cleavage of HF molecule in the liquid HF solvent. All right, so basically we will write 3HF gives you H2F positive, all right, and along with that HF2 negative. So this is what you are going to get. All right, so this is what you get in the autoionization of hydrogen fluoride. Now, this was about the autoionization. If you are talking about the neutralization, it's going to be just the opposite reaction of this. Okay, so who is going to act as an acid and who is going to act as a base in this solvent? Let's see. Okay, so let's talk about yes, let's talk about acetic acid. What is the ion it's going to furnish? COO minus, and that gives you an H plus. It's going to break like this, right? But yes, but tell me one thing, guys. Is it possible that I am breaking the acetic acid in this way? Is it possible that it's going to give you H2F positive? Yes. Is the acetic acid going to behave as an acid in the liquid HF? What do you say? Is it going to form this ion? Yes or no? Right. It is very simple that any acid will want to leave the proton and will want to form this. But is the acetic acid going to form the same thing? Acetic acid in the presence of HF is going to rather take this proton from the liquid HF molecule and generate F minus. So what does it behave? What is the behavior of acetic acid in HF? Acetic acid in hydrogen fluoride, what does it behave like? An acid or a base? Yes, Jaya, very well. It is acting as a base in the liquid HF molecule. So this is what we are here to compare. We are here to compare all the properties of different acids and bases in different solvents, right? So yes, let's also talk about more acids. Okay. Also, there is one more thing. Whenever you create an F minus, you are going to write HF2 minus for the same reason that I told you, because it's going to be hydrogen bonded. So let me write the overall equation: CH3 COOH plus 2HF, that gives you CH3 COOH2 positive plus HF2 negative. So what do we call this? If it is forming the solvoanion. Okay, we call this the solvoanion. Why do we call this solvoanion? Because when we were doing the autoionization, see, when we were doing the autoionization of HF, we saw कि एक बनता है solvent cation, which we call the solvocation, एक बनता है solvoanion. So this one is the solvoanion, right? So this must be clear to you that any species or anybody who is going to provide a solvocation, anybody who is providing a solvocation, okay, in liquid HF, that is going to behave as a acid. All right. And anybody who creates the solvoanion in liquid HF, that is going to behave as a base. All right, so this is what we are going to look at finally, and that's why we say that acetic acid, see, acetic acid in the presence of liquid HF has created the solvoanion, so it is working as a base. Okay, it's not working as an acid. All right, now there's one more thing, guys. There is one more thing when you compare it with more stronger acids. Let's say you compare it with nitric acid, HNO3. So usually nitric acid is a very strong acid. Okay, nitric acid का जो हम pKa check करते हैं. Let's say you know just normally talking about the pKa of nitric acid as well as HF. So HF is going to be 3 point something and nitric acid is minus 1.5 something pKa. Right, so these are the pKa values in the presence of water as a solvent, isn't it? ये water solvent में ली जाती है pKa value, but it is not necessarily said कि nitric acid is stronger than HF, because what we see is कि nitric acid को, if we are reacting this with, once again, if we are taking the nitric acid in the liquid solvent, hydrogen fluoride, what will it do? It is protonated. Okay, it is protonated to give you once again the solvoanion, right? So even the nitric acid is going to behave as a base in the liquid HF. Similarly, a very strong acid H2SO4, a very strong acid H2SO4 in the presence of liquid HF is going to provide you the same thing, H3SO4 positive plus HF2 minus. Now you would say that that sulfuric acid is the strongest acid. Why have you written the reaction in this way? But sulfuric acid is a strong acid in the presence of water. So water is having a leveling effect, right? Water is a basic solvent, right? Basically an amphoteric one. But HF is a acidic solvent, right? And water is a basic solvent compared to HF. So that's why you always say that H3SO4 is H2SO4 is a strong acid in water, not in HF. Now let's move to an even stronger acid. अब ये sulfuric acid is also behaving as a base in HF, right? So what do we say next? कि इससे भी strong acid हमने ले लिया, let's say HClO4 we are taking for example, even stronger than H2SO4. What is going to happen then? In the presence of HF, all right, along with this, it's also giving you this reaction. So basically, HClO4 is behaving amphoteric. It is behaving amphoteric in the presence of HF, right? Why? क्योंकि ये क्या है? This is much stronger than H2SO4, and it is also taking the proton. It is also losing the proton to give you both of these, the solvoanion and the solvocation. That's why the behavior of HClO4 in liquid HF is going to be amphoteric. This is what you have to remember, right? Just Note it down somewhere because these are like very, very important reactions. Okay, and now we are going to move onwards to another solvent system, that is going to be liquid BRF3 bromine trifluoride. Okay, all right. Yeah, let's see what's happening over here. So in the liquid bromine trifluoride, once again, we are going to start with the autoionization process. So autoionization process, it's going to be in this way. The molecule is going to break down, right? It is going to generate BrF2 positive plus F negative. But what happens is the F minus is going to get one more solvent, and let's write the overall equation. 2 moles of BrF3 breaks down to give you BrF2 positive plus BrF4 negative. Okay, yes, absolutely. So which is the solvo anion and which is the solvo cation? This is your solvo cation. This one is solvo anion. So anybody, any species which generates the solvo cation, okay, is going to behave as the acid. Anybody who creates solvo anion is going to behave as the base. Okay? Yes. All right. So now first example we see is if we are having these kind of molecules, guys, जैसे कि PF5. All right. What do you say? Okay. All right. So PF5, BRF3, what is going to be the product? What does it behave as? Acid or base? Right. So basically, it's very, very simple. When you are having PF5, it is having inherent property to take away the fluoride so that it can form PF6 minus the hypervalent anion plus BrF2 positive. So, so definitely this is forming the solvocation और solvocation होने की वजह से PF5 is acid. Okay, any more examples about PF5 just like this one? Any more examples of species behaving as acid? Base PF5 होगा. Base कैसे होगा? This is going to be the acid. It is a Lewis acid. Behaving as a Lewis acid over here because it is accepting the fluoride from the BRF3. BRF3 is donating the fluoride, right? So this is the base. Alright. PF6 minus is your conjugate base. ये acid है, ये इसका conjugate base pair है. This is your base और ये हो गया इसका solvocation, the conjugate acid pair. Isn't it? Right. So let's see more examples. अभी PF5 जिस group में है, you also have antimony pentafluoride. So antimony pentafluoride के लिए you can see the same reaction. BrF2 positive and antimony hexafluoride, once again like this. So this is also a Lewis acid. That's why accepting the fluoride to give you this conjugate base, and क्योंकि ये acid generate कर रहा है इसीलिए हम इसे बोलेंगे this is going to be the acid. Now these are there in the same group. What about SiF4 and SnF4? So they are also in the same group, group number 14. Here if we are adding BrF3, we have to add 2 moles of BrF3 so that it becomes SnF6. 2 minus, it's becoming octahedral, and there are it's getting two fluorides from the boron trifluoride, right? And along with that you have 2 moles of BrF2 positive. Once again this is also behaving as an acid. So similarly और क्या example हो सकते हैं हमारे पास में germanium fluoride भी हो सकता है GeF4. We can also have some D block elements like AuF3, right? It can also accept one fluoride to form the tetrahedral or the square planar complex, and then also it's behaving as the Lewis acid. ये सारे के सारे क्या करते हैं? They are all generating the solvocation. They are all generating the solvocation, and that's why all of them are going to behave as the acid. ठीक है? Okay. What about bases? जैसे कि if the, if there is anyone who is creating the solvoanion is going to behave as a base. जैसे कि the simplest example is KF. All right, because it is ionic, it's going to form K plus BrF4 minus. तो ये क्या बन गया? Solvoanion, right? So if it is the solvoanion, KF is going to behave as a base over here, right? This is going to behave as a base. Now let's say if I ask you a question, ki what will be the products? Okay, let's say I ask you a question, what will be the products of this reaction KF plus SbF5 plus 2 moles of BrF3. Okay, what does that give you? इसके क्या products होने चाहिए? Looks like it's going to be kind of a neutralization reaction. Why? Because you have taken the acid. This part is the acid, this part is the base, isn't it? But since you also have to mention the role of BrF3, so what you are doing is there are two BrF3 given over here. One of them is going to take away the fluoride from here. So एक BrF3 क्या बन जाएगा? K plus BrF4 minus. ठीक है? One of them is going to form this species. The other one is going to form BrF2 positive. SbF6 negative. Okay, so these are your answers. It could be a neutralization reaction if the BrF3 is not mentioned. If it is mentioned in the question, आपको इस तरीके से लिखना पड़ेगा, right? That is, you are forming the solvocation as well as the solvoanion. Both of these you are forming at once. Okay. Yes, absolutely. This is your answer. Now there are other molecules guys जिसके पास fluoride नहीं है. Let's say we have seen all the examples of molecules which are having the fluoride. लेकिन जैसे कि I am talking about germanium oxide. It doesn't have a fluoride. So what is it? Its behavior in BRF3. See, basically BRF3 is an interhalogen compound. जो interhalogen compound होते हैं, their bonds are very weak and they easily dissociate. And since BRF3 has a huge difference in the size, it's going to be a very good fluorinating agent. तो ये क्या कर देगा? Germanium को it's going to form the BRF2 positive since it's breaking down the fluoride bond, and it's going to fluorinate germanium like this. Okay, it's going to fluorinate germanium, and germanium oxide once again acts as a Lewis acid because it is generating the solvocation. ठीक है, so since it is a very good fluorinating agent, इस type के molecules जिनके पास fluoride नहीं है, they are going to also act as an acid. So I have taken antimony pentaoxide, okay, on its reaction with BRF3, it's going to once again give you BRF2 positive, along with that antimony hexafluoride. Okay, yes, so once again this will also behave as an acid. All right, all right, so if we try to do some questions on this, बहुत ज़्यादा simple है ये. Okay, if we try to do some acid based questions, let's first start with an easy question, right? All right. So what you have to answer is, this is your question number 1. You have to mention, pick all the gases which dissolve in water to give an acidic solution. Okay? Yes. So first thing you have nitrogen. Second you have carbon dioxide. Third you have sulfur dioxide, sulfur trioxide. You have ozone. You have HBr. ठीक है? तो इनमें से which one of these are going to dissolve in water to give you an acidic solution? Option number A is 1, 3, 4, 6. Option number B is 2, 3, 4, 6. Option number C is 2, 3, 6. And option number D is 2, 4, and 6. Alright, so you can check it out from here. Alright, so this is a very simple question, guys. The answer is option number D. Why? Because Pick all the gases which dissolve in water. So nitrogen is neutral, it's not going to dissolve in water. Carbon dioxide, while dissolving in water, gives you carbonic acid H2CO3. SO3 gives you H2SO4 because it is the acid anhydride. It is the acid anhydride of sulfuric acid. Ozone is not going to give you any acid, and HBr is going to dissociate into ions. So this is also acidic. So 2, 4, and 6. So this is your correct answer. All right. Moving on to another question is arrange the hydrides. All right, or you can write it better as so which one is correct order of acidity of hydrides? Right. So the first option goes like this: methane less than H2SE less than H2O less than GeH4, CH4 less than GeH4 less than H2O. All right, so yeah, which one is the correct answer out of all of these? It's a simple trend, guys. A question based on just trend. Um, okay, we can just write H2O less than selenium H2Se. ठीक है? Yes. No, guys, it's a simple question on trend. The answer is as simple as that. When you are moving down a group, whenever, whatever group it is, let's say CH4 and GeH4, let's compare separately H2O, H2Se. So the acidity of hydrides will depend on the size mismatch, isn't it? Right. So whenever you are moving down any kind of a group, right, the size of hydrogen is small and the size of the central atom goes on increasing down the group. So that is why this is going to be more acidic. So GeH4 is going to be more acidic as compared to CH4, and H2O is going to be less acidic as compared to H2SE. Now we just have to combine this. So we will just compare that from here to here what happens. The size decreases, electronegativity increases, and the acidity also increases. So just one more sign over here. Answer is option number B. Okay. So you just had to use this concept that down the group the size is going to increase and the acidity decreases. Okay. Chalo. So we do another question, guys. And once again, comparing acidities. Question number 3. So you have to compare the correct order of acidic strength of trichloroacetic acid, trifluoroacetic acid, acetic acid, and formic acid. So which is the correct option? Okay, what is the correct order of acidity? Simple question, guys, very simple question. See, there's one thing. Obviously, you know that trifluoroacetic acid is going to be stronger than the trichloroacetic acid because of a greater minus I effect of the fluorine. And that in turn is going to be more acidic than the simple acetic acid. But you are missing out on one thing. You are missing out on the comparison. Yes, Krishna, very good. Yes, yes, C is going to be the correct answer. You have to see that 3 and 4 you have to match. This is formic acid and this is only having one carboxylic acid and there is the plus I effect. There is this plus I effect of the methyl group, right? So 3 is not going to come over here, it's going to shift a position back, and 4 is going to come over here, right? Formic acid more acidic than the acetic acid. So C is your correct answer. Okay, so we do one more question, that is select the order of effectiveness of the Lewis acid catalyst in the Friedel-Crafts reaction. Okay, so your option 1 is like this. Be very careful. Alright, so which of these is your correct order? No, no, no. No, Nikita, not like that. CCl3 as well as CF3. यहाँ पे डायरेक्ट क्लोरीन और हाइड्रोजन का या फिर फ्लोरीन और हाइड्रोजन का बॉन्ड ब्रेक नहीं हो रहा है. सो हियर वी डोंट सी द साइज फैक्टर. ठीक है, हियर वी सी द माइनस आई इफेक्ट. Who has a greater minus I effect? We see the electronegativity factor. So fluorine has a greater minus I effect as compared to the chlorine. So that's why your trifluoroacetic acid is stronger. Okay, जब direct CLH और FH bond break होता तब हम size factor देखते. All right. Yes, let's focus on this question. Select the order of effectiveness of Lewis acid catalyst in the Friedel-Crafts reaction. Or let's say you already know the Friedel-Crafts reaction, right? Yes. So why is the order the way it is? Yes, Krishna, you are almost correct. Just that the BF3 is going to be at the last. Why? Your answer has to be option number A. Because BF3, all right. So the overall order is Lewis acid. The best Lewis acid, the one who is the best Lewis acid is the one who is the most electron deficient. Is the one who is the most electron deficient. Okay? So AlCl3 is the most electron deficient. It only has 6 electrons. Now BF3 also looks like it has 6 electrons, but it has pi back bonding from fluoride. And what is the bond order of the pi back bonding? Pi back bonding bond order is 1 by 3. Okay, so you have the pi back bonding over here. FeCl3, iron is there in the +3 oxidation state. Zinc is there in the +2 oxidation state. So you go like this. Okay, +3 and +2 in this way. So your answer has to be option number A. All right. Yes. So this is the order of effectiveness of Lewis acid catalyst in the Friedel-Crafts reaction. More electron deficient, better Lewis acid it will be. All right. So guys, we did very few questions, very simple questions over here. और बाकी जो है, we have already had the practice sessions on acids and base in the battle of poles, as you already see. So yes, in the battle of poles we have already studied acid base is done, and along with that main group elements is also done. What we are doing right now is coordination. So in the Battle of Pole, every day 10 a.m. we are doing coordination chemistry, and in the month of November we will start organometallic chemistry as well. Okay? Yes. So guys, ये जो आपका inorganic का crash course है, this one, here also we are doing practice of all the important topics. Now here we are taking some really good new questions from the books, from the examples. right? Some really good new questions to be solved on each and every topic, right? No, Anirudh, usually I only teach for CSIR NET and GATE, okay, and also TIFR. So if you are interested, you can just check out my profile, because in the profile there will be all the courses that you get for the CSIR NET and GATE, right? And if you are interested in joining, you can join up using this subscription offer right now. This is going on from 14th to 20th of October only. Okay. So if you are taking a 24-month subscription, that is a 2-year subscription, you'll get free the 3-year subscription as well. And don't forget to use the code Jagriti S Live. That is the code for the 10% offer, 10% discount. Other than that, okay. All right. So, yes, guys, now I'm going to see you tomorrow 10 a.m. Another Battle of Pole session. Tomorrow 10 a.m. as always is going to be coordination. Okay? And yes, till then, bye everyone. Have a very, very good night. I hope that you have studied a little bit of acids and bases from the previous and this session, right? More sessions are coming up like this. All right, guys, have a good night, all of you, and sweet dreams. Bye, everyone.